In this video, let me show you how to put together what we did in the previous videos. So I'd like to summarize it, give you the notation, and this will be the step-by-step method for calculating areas using this method, which is known as Riemann sums. So let's say that we have a continuous function over an interval, a to b, along the x-axis, and we want to find the area of the region underneath that curve and above the x-axis. So first of all, we're going to split the region into n rectangles of equal width. The width of each rectangle will be known as delta x. Delta x represents the width of each rectangle. And the way you find out what the width is you find the length of the entire interval, which is b minus a, and you divide it by the number of rectangles, which is n. So the formula for delta x, which is the width of the rectangle, is b minus a over n. Now, when we split this up into intervals, or into rectangles, the right endpoint of rectangle I is called x sub I. And the way that you get x sub I is you take the left endpoint A and you add delta x I times. So the formula for the right endpoint of rectangle R sub I is A plus delta x times I. So if we determine the height of each rectangle using the right endpoint, you'll get that by taking x sub I and substituting it into the function f. So the height will be f of x sub I, where x sub I is given by this formula. So that means that the area of R sub I is going to be its height times its width, which will be f of x sub I multiplied by delta x. So the total area of the n rectangles will be the sum I equals 1 to n f of x sub I times delta x. And this sum is known as a Riemann sum. It's getting a little small, so I'm going to recopy it up here. Now, Algebraically, once you get this Riemann sum, you're going to be able to expand it out like I did and substitute in summation formulas like this and get a formula for what the area is using this right endpoint approximation. And then finally, the exact area under the curve will be the limit as n goes to infinity of the Riemann sum. In other words, you're going to take more and more and more rectangles. So you get to this point, you expand it out, plug in those formulas, and simplify. That gives you a formula involving n, and then you let n go to infinity. It turns out that if you use the left endpoint, you'll get the same answer, provided the function f is continuous. So this is going to be the area provided the limit converges, and something I'll ask you simply to trust me on is that if f is a continuous function, then this will converge, and you'll get exactly the same answer as if you use the left endpoints. It just turns out to be algebraically easier to use the right endpoint approximation. So let's work some examples in the next videos.